Let's talk about limits. So a limit is written like this. And these are the symbols used. So it's read like this: limit as x approaches c of the function f of x approaches or equals to L, which is the actual value. So basically this, when you plug in something, when you plug in c here, the value of f of x either approaches or equals to L. So let's see how this works. So let's say I have a function y is equal to x squared plus 4. And let's say we ask the question, what's the limit as x approaches 7 of this? So x squared plus 4. So this means that when we plug in a number, a value very close to 7, not exactly 7, but something that approaches 7, arbitrarily close to 7, for x, the function will equal whatever's here. So when you plug in a value for x that approaches 7, this is going to be 49 plus 4 is 53. So it approaches or equals 53. So now that we see how that works, let's use another example, but start with a graph. So let's say we have a graph, and it's defined differently at each part. So alright, so let's say it looks like that, and the values are, that can be 4, 2, alright. So this is our graph, and this part is y is equal to x squared. This part here is y is equal to minus x plus 2. That part there is y is equal to x minus 2. And this part here is y is equal to x minus negative x plus 8. Now this isn't actually important, but I have defined these functions. So what's the limit of f of x as x approaches 0? So for this, we have to know another rule for limits, the main rule. So this limit here can only exist if one thing holds true. And that is that the left-handed and right-handed limits have to equal the same thing. So this what I'm saying is that the limit as x approaches c from the left, which is written like that with a minus sign, of f of x must equal the limit as x approaches c from the right of f of x. So this is how that's written, and this here is imperative. It has to hold true for this limit here to exist in general, for a limit as x approaches c exists. But these individual limits can exist by themselves as x approaches c from the left and c from the right. But if they're equal, then the limit as x approaches c, we can say exists. So the limit as x approaches 0 here, does it exist, does it not exist, and if it does, what's the value? So if we look at the function, the limit as x approaches 0 from the left, so if we come from the left, f of x is equal to, so we're coming from the left, and that's equal to 0. And the limit as x approaches 0 from the right of f of x, so if we come from the right and we go here, that's equal to 2. So these two are not equal, therefore this limit here does not exist. Alright, and over here, what's the limit as f of x as x approaches 5. Now this is interesting because the limit, let's see, limit, so what has to hold true for this limit to exist? If the limit of x approaches 5 from the left is equal to the limit as x approaches 5 from the right. So as this approaches 5 from the left, it is equal to 2. It's coming from the left, and it's 2. And from the right as well, again, it's 2. So this limit of f of x as x approaches 5 is actually 2. Even though it's not actually the f of c at that point doesn't really equal, f of 5 doesn't really equal the same thing, because it actually equals 4, because f of x at 5 is equal to 4. So why does that matter? Well, it doesn't, because we only care about what happens as it becomes arbitrarily close to 5. It doesn't matter what it is when it actually equals 5, which is 4. We just care, and when we're talking about limits, we only care about what happens when we get really, really close to this number here. So as long as it's getting really close, it's still always going to approach 2. That's it. Thank you.